Welcome to CubeSatVR Studio, a directional and hands-on based learning experience to learn the fundamentals of technical skills necessary for understanding and working with CubeSats, providing a practical and engaging approach to mastering the principles of satellite technology and electronics. Click one of the images under the Experiences tab with your Oculus remote in order to be transported to the activity. Welcome to your first learning activity. You are currently inside a clean room, used to design and build aerospace-related projects such as the CubeSat you are about to learn about. Feel free to explore the room before we continue. In front of you is a 1U Cube satellite measuring 10 by 10 by 10 centimeters. CubeSats provide a cost-effective platform for science investigations and new technology demonstrations in space. The outside of the Cube satellite, also known as the chassis, is surrounded by solar panels, absorbing the sun's energy while in space. On the top of the Cube satellite is a radio, communicating information from your Cube satellite back to Earth. Overlap your hand with the top plate in order to learn what's inside of the CubeSat. Inside of the CubeSat is the fast bus, which contains the batteries charged by the solar panels. The batteries power almost all essential components inside of the CubeSat. The remaining space inside the CubeSat is used for the payload, which will be discussed in the next learning activity. For the next activity, you will be completing an LED circuit. Understanding circuiting is an important skill to master when working with CubeSats or any form of electronic design work. To begin the activity, pick up the LED light and place it on the right side of the breadboard. Next, pick up the resistor laying on the table and place it next to the LED light and make sure the two pins close the gap between the different sides of the breadboard. The resistor regulates the amount of voltage flowing into the LED, making sure it does not burn out. Next, connect the wire from the positive output of the power supply blocks onto the positive rail of the breadboard. Repeat the same process for the ground pin. Next, transfer the power from the positive rail of the breadboard to the same row as the resistor. Repeat the same process for the ground and connect it to the ground pin of the LED light. For the final step, change the voltage on the power supply blocks to 3 by overlapping your finger with the dial. As you can tell by the illuminated light, you successfully completed your first LED circuit. How can this process be replicated on a smaller scale to fit within the parameters of a Cube satellite? For this, we can utilize various different components, such as a PCB board, in order to replicate similar results as we just completed without using the space of the breadboard that we don't need.